All right, here we are in chapter 4 on section 6, matrix equations and systems of linear equations. All right, so here we have matrix equations. So solving simple matrix equations is similar to solving real number equations, but with two important differences. There are no operation of division for matrices, and matrix multiplication is not commutative. Because remember, if we have a 2 by 3 and another one's a 3 by 4, you can't switch those around. Now, we would solve the real number equation for x equals 9 by dividing both sides of the equation by 4. And that would give us our 9, our 9/4. And similar approach is not possible though with matrix because we have to say ax equals b, matrix A and b and x, and division is not defined. So what we have to do is we have to think about what else we could do. If we think of multiplying the equation 4x equals 9 by the multiplicative inverse of 4, which is 1/4, and then also multiply the 9 by 1/4, that's going to be something similar to what we can do with matrices. So if we have ax equals b, if we multiply a inverse on the left as well as the right, then we'll end up a inverse times a is going to give us I times x, which is x. And then we'll have a inverse times b, and that's going to give us our new answer for x. So there are several conditions required for this proposed solution. Matrix A must not be singular. So in other words, you have to be able to find the inverse, okay? And because matrix multiplication is not commutative, multiplying both sides of an equation on the left by A inverse is different from multiplying both sides of the equation on the right by A inverse. Now, assuming that all products and sums are defined for the indicated matrices A, B, C, I, and 0, then we have addition properties, associative. Well, A plus B is, and then add C after that is the same as A plus B and C together. We have a commutative property, add both ways. Adding the identity to both sides still gets the A. Additive inverse, A plus A negative A is same as that. Multiplicative properties, we can take B times C first and then times A, or A times B first and then times C. And the identity multiplying on the right or the left gives us A still. And in multiplicative inverse, if A is a square matrix and A inverse exists, A times A inverse is the same thing as A inverse times A, which is I. Now, combining properties, left distributive, A times B plus C is equal to AB plus AC, just kind of distributing. Right distributive, well, now we'll have BA and CA, just kind of taking it the other way. Equality. Now, if A is equal to B, then A plus C is equal to B plus C. So we're just adding the same thing to both sides. Left multiplicative. Now A equals B, then CA equals CB. Right multiplicative. A equals B, then AC equals BC. And then let's do an example. So given an n by n matrix A and an n by 1 column matrix B and X, solve AX equals B for X, assume all necessary inverses exist. So we have to assume everything is going to work. Okay. So we're going to seek a column matrix X that satisfies the matrix equation AX equals B. Okay. Now to solve this equation, we're going to multiply both sides on the left by A inverse. So remember, if you take A inverse times A, that's your identity. And then what happens is on the right, we're going to have A inverse times B, but on the left, it's I times X. Remember, I times X is just X. So now we have X equals A inverse B. And so going through all that, this is what we have. X equals A inverse B. And so, that's what we're doing here, just using our associative property, multiplicative property, and all that stuff. All right, so what we want to do is we want to use matrix inverse methods to solve this system of equations. So first things first, let's make a coefficient matrix. So we have 1, minus 1, 1, 2, minus 1, 2, 3, and 0. So we have all those values plugged into here. And again, what we have to do is we're going to assume they're going to give us a matrix that's going to give us an inverse. Now we're going to convert the system into a matrix equation. Now remember, if we have the x, it's going to be x1, x2, x3. And so that's what we have here for the x. Our coefficient, the x, the b's, which is on the here. Now the inverse of a, which is really nice, they give it to us. Calculator does it really quick too. So if nothing else, use your calculator if they don't ask for it to be worked out longhand. And so we can take x is equal to a inverse times b. Now when we do that, we just multiply, 3 plus 3 is 6, minus 1 is 5, and so on. And so then what happens is x1 is 5, x2 is minus 3, x3 is minus 7. So it works out quite nicely when you do this. All right, so let's stop there and we'll come back for some more.